Alright, so today we want to look at kind of the reverse of what we have been doing. So our instructions are going to be write a polynomial that has the roots (0, 3, and -2. Alright, so tell me some synonyms for the word roots. What are roots? They're zeros. Excellent. What's another synonym? They're the x-intercepts. And hopefully what you have a very good understanding now is that the roots are related to the factors, right? So if I step aside from this problem, if I told you that a polynomial had a factor of x plus 3, what would a root be? A root would be -3. So you know how to look at a factor and go to a root. All this is going the other direction. I'm telling you the root, you're going to back up and go to the factor. Alright, so if there's a root of 0, what's the factor? Just x. If there's a root of 3, what's the factor? X minus 3. And if there's a root of -2, what's the factor? X plus 2. And now we're just going to carry out the multiplication. And multiplication can be done in any order, so if you wrote yours in a different order, it's still going to work out. I'm going to multiply my two binomials together first, just because I like to do that. So I'm going to bring down my x, then I'm going to go x times x is x squared, x times 2 is 2x, I'm just going to hold that in my head for a second, -3 times x is -3x, I'm going to combine those like terms and get -x. If you have a harder time holding that information in your head while you combine like terms, of course, just write that step out. -3 times 2, -6. Then I'll go through and distribute the x, and I'll have x cubed minus x squared minus 6x. There's my polynomial. Well, I'd like to check this. And we have calculators, so how do you think we could check it? If I'm checking it, what would I be checking for? I can check the graph, and what would I look on? What part of the graph would I look on? The x-intercepts, right? So take your calculator, come grab one if you don't have one, and let's type in this polynomial. X to the third power minus x squared minus 6x, and I'm going to graph that, and I'm looking for my x-intercepts. I have an x-intercept at -2, I have an x-intercept at 0, and I have an x-intercept at 3. Looks like a great polynomial. The other place you can check is you can go to the table. So second graph will get you to table. And if we're at 3, do you see that the output, sorry, there's glare there. When x is 3, the output is 0. That tells me that there's a root of 3. When x is 0, I have an output of 0. And when x is -2, I have an output of 0. So that verifies that those are in fact roots of this polynomial. Now, this is not the only polynomial that has those roots, but this is the least degree polynomial, right? We could multiply by some other things, and get other polynomials that have those roots, but this is the one that I guess is kind of like the most basic with those roots. Does that make sense? All right, let me give you one to try. So you're going to write a polynomial with the roots 1, 2, and -4. All right, if you are watching this lesson on video, pause the video and do that right now. All right, so the first step to getting this right is to write the three factors: x minus 1, x minus 2, x plus 4. So if you wrote your factors down, that's the correct first step. Then you have to multiply two binomials together. So I'm going to multiply x times x is x squared, and then I've got negative 2x and negative 1x, so I've got negative 3x, and then I've got plus 2. And then I have to multiply that by x plus 4. So then you can either distribute your x squared to those two terms and go in that direction, or you can distribute your x to those three terms. It can be done either way, and they're both correct. Yes, it is. But just know that if you're working with partners and one of you distributes one direction and one of you distributes the other direction, you're going to have all the same numbers, but they might be in a different order until you combine your like terms. Once you combine your like terms, you want your polynomial written in descending degree, right? So we want to start with x cubed plus x squared minus 10x plus 8. Then you're going to check it. And again, to check it, you're going to use a calculator. And you're going to go to y equals, type in your polynomial. On your graph, you're looking for your x-intercepts. On your table, you're looking for wherever y is 0, because that's what roots mean. Okay, well, these two examples all had integer roots. What if I told you that one of the roots was 1/2? What's a factor going to be if the root is 1/2? Yes. How'd you get that?
If you said x equal to 1/2, you multiply by 2 to one side. Subtract 1 to get that equal to 0.
So this root, right, is my x value. So if I set x equal to 1/2, and then I multiply both sides by 2, then I have 2x is equal to 1, and I want this to be equal to 0, so I subtract 1 from both sides, and I have 2x minus 1 equals 0. So if my root is 1/2, my factor is 2x minus 1. So if you just remember that your root is your x value. So that's literally just what we wrote down. X equals 1/2, and then we solved and set it equal to 0. All right, pause this.